Dear students, in this uh, fifth lecture, we are going to discuss statistical quality control. Now, see what is statistical quality control. One of the most important applications of statistical techniques in industry is a statistical quality control. The term quality simply defines how well a product or service meets the set parameters and satisfies customer needs or demands. The statistical techniques are used to measure the quality of product or services. The term statistical quality control is abbreviated as SQC. In general, statistical quality control is statistical process control which monitors a production or service process which affect the quality of the end product. This is achieved through the technique of control charts. In simple terms, we can say that the best advantage of SQC is in the control, maintenance, and improvement in the quality standards of a product or manufacturing process. Now, see what is control charts. Control charts are defined as the most important tools in production management and the control of quality in the manufactured product. Its theory was invented by Walter Shewhart of Bell Laboratories in the mid 1920s, and it was W. Edwards Deming who explained Shewhart's theory and put it into practice. The control chart simply determines whether a process is in or out of control. Its purpose is to locate and, if possible, eliminate assignable causes of variation. Control charts are simple pictorial device for detecting unnatural pattern of a variation in the data and checking whether the process is in statistical control or not. A control chart consists of control limits and central line. You can see here the control chart simply determine whether a process is in or out of control. There are two control limits: upper control limits, that is given by UCL, and lower control limits. As I told you, a control chart consists of control limits and central line. These are the two control limits given by LCL. This is dotted line LCL and this is UCL, and this is a central line. See this one. The distance from upper control limit or lower control limit from central line is 3 sigma. See, on X axis I have given the sample numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On Y axis we have given quality scale. A process is said to be in statistical control when all points lie in between LCL and UCL. LCL, that is lower control limit, UCL is upper control limit. If any of the point lies outside this interval, then the process is not in statistical control. Lower or upper control limits is given by LCL is equal to mu minus sigma 3 sigma and UCL is equal to mu plus 3 sigma. Mu is mean and sigma is estimated standard deviation. Now, classification of control charts. How the control chart is classified? Control charts has divided into two parts. The first one is control charts for variables and second one is control charts for attributes, this one. Again, control charts for variable is divided into two parts. Average chart, this is given by X bar chart, and second one is range chart, this is given by R chart. And control charts for attributes is also divided into two parts. First one is charts for defective items and second one is charts for defects per unit. In the charts for defective items, again it is divided into two parts. The first one is fraction defective, that is varied sample size. This will be calculated by P chart. And the second part of it is number of defective constant sample size, and that is calculated by NP chart. In the charts for defects per unit, again it is divided into two parts. The first one is constant sample size, that will be calculated by C chart, and another one is varied sample size, that will be calculated by U chart. So control charts for variables variable control charts are used to measure characteristics such as volume, weight, time, pressure, concentration, etc. The control charts used in this case are X bar and R charts, X bar and sigma charts, that is ST. This chart is commonly used in industrial engineering and scientific applications. For each sample, the average charts X bar of all the measurement and the range chart R are calculated. The grand average X bar is what? Equal to the average value of the sample average, and R bar equal to the average of all the sample ranges are found, and from these we can calculate the control limits for X bar and R chart. Now see, how will you find the X bar and R charts? Simple definition is here. See, X bar, the X bar chart. The X bar is used to trace the undesirable variations between samples. Let mu and sigma be the process mean and standard deviation respectively. If bar of X bar gives the mean of the sample means, then standard errors of sample mean is given by sigma by under root n, where n is sample size. If the population mean is known as the central line is at mu, otherwise at bar of X bar, where bar of X bar is equal to 1 upon k summation X bar. K is number of periodic samples selected. Now control limits for X bar chart. See, the 3 sigma control limits for X bar charts are: the lower control limit LCL is given by, this is the formula, LCL is equal to mu minus 3 into sigma by under root n. Also LCL is equals to bar of X bar minus 3 into estimated standard deviation, where mu and sigma are not known, and the upper control limit UCL is given by, UCL is equal to mu plus 3 sigma by under root n, which is equal to bar of X bar plus 3 into estimated standard deviation, when mu and sigma are not known. Now calculation of mean, range and control limits. To check whether the process is in state of statistical control or not, let us suppose that random samples each of fixed size n is plotted up from lot. Let x1 bar, capital X1 bar, capital X2 bar, dot dot, capital XK bar be the means of first, second, dot dot, kth samples, while capital R1, capital R2, dot dot dot, capital RK be the corresponding range of the k samples, where xi bar equals to 1 upon n sum of all observations, where I runs from 1 to k. So capital Ri is equal to capital XL minus XS, where XL is largest observation and XS is smallest observation. Again, bar of X bar is equal to mean of the k sample mean, R bar is equal to mean of the k sample ranges. Then bar of X bar is equal to 1 upon k summation I from 1 to k xi bar, and X bar is equal to 1 upon k summation x from I to k Ri. Let us define mu is equal to process mean and sigma is equal to standard deviation. Then E of X bar is equal to mu and S E of x bar is equal to sigma upon under root n in the bracket standard error of sample size, sample mean. N is equal to size of sample mean. Hence this 3 sigma, this one, 3 sigma control limits for x bar chart are. First one is when population process mean mu and standard deviation sigma is known, E of x bar plus minus 3 s into E of x bar is equal to mu plus minus 3 sigma by under root n is equal to mu plus minus a sigma, where a is 3 by under root n. Second one, when population process mean mu and standard deviation sigma are not given, in that case UCL for x bar is equal to bar of x bar plus a2 r bar. LCL x bar is equal to bar of x bar minus a2 r bar. Control line for x bar is equal to bar of x bar. The R chart, we are going to have the R chart. This chart is used to track process variation. It is used when the production or service process is higher. This results in a wider range of value of produced or serviced items. Now control limits for R chart. What is the control limits for R chart? The R chart is used to track process variation within samples. The the 3 sigma control limits for R chart are UCL R is equal to D4, capital D4 R bar, and LCL R is equal to capital D3 R bar. In case sigma is known, then UCL R is equal to capital D2 sigma. LCL R is equal to capital D1 sigma. In both case, sigma known or unknown, CLR is equal to R bar. Alright. Here capital D1, capital D2, capital D3 and D4 are constants and their values depend upon the sample size n. Their values are always given. It is also to be noted, to monitor the process variation, two charts are generally used, namely the R chart and the S chart. Let xi bar, capital Ri bar and capital Si denote the subsample summary values. Let bar of x bar is equal to summation I from 1 to k capital Xi bar upon u, comma, R bar is equal to summation I from 1 to k capital Ri upon u, and S bar is equal to summation I from 1 to k Si upon u. Let capital C2 be the factor of control limits. The x bar chart on the S bar consists of what? Control limit is equal to bar of x bar. Lower control limit is equal to bar of x bar minus capital C2 into S bar. Upper control limit is equal to bar of x bar plus capital C2 S bar. These all has the value given in the table. The rest of the charts and the related values will be discussed in the lecture 5th. Next lecture, you can say whatever it is, 5th, 4th, whatever it is. So this is all about this statistical control, quality control and control charts. So where it is used, how to use, and what are the different charts, how to find. I have already, the main thing in this, the main line you can remember, that a process is said to be in a statistical control when all points lie in between UCL and LCL. This is our main aim. Now how to do? With the help of the different charts we can do. So okay, the rest of the things will be discussed in the next lecture. Thank you so much.